Good day, students. So welcome to part 2 of the Algebra 1 Regents exam for fall 2013. We're going to be going over problems 2 to 5 in this installment. All right, let's take a look at problem 2. It says, if the quadratic formula is used to find the roots of the equation x squared minus 6x minus 19 equals 0, the correct roots are. So this problem is assessing our ability to accurately apply the quadratic formula. So let's write down what the quadratic formula is first, and then we're going to use it to find the roots of this quadratic equation. So the quadratic formula says that the solution to a polynomial in standard form, ax squared plus bx plus c equals 0, is the solutions are are given by the formula x equals negative b plus or minus the square root of b squared minus 4ac. Now note, the entire this entire term is divided by 2a. One mistake that most people make is that they divide only the radical piece by 2a, but you divide the entire expression that we just wrote by 2a. Okay? All right, so in order to use this formula, we just need to find a, b, and c and plug them into the quadratic formula. Use the order of operations to simplify our expression, and that will be our roots. Okay, those will be our roots. So we have x squared minus 6x minus 19 equals 0. Now, a is a coefficient of the square, so since there's no number in front of the x squared, we just put a 1 there. That's a multiplicative identity, so we can see here that a is equal to 1, b is negative 6, that's a coefficient of x, and c is negative 19. All right, you see a, b, c there? So here you have a, b, c. The degrees have to be in descending order. This has a degree of 2, 1, and 0. Okay? Now that we have our a, b, and c, we are going to now apply it to the quadratic formula. So the quadratic formula using these values is going to become negative b, negative 6. Now notice what I just did. There was a negative here before, so when I introduce b as a negative number, I put it in parentheses, okay? This minus has nothing to do with that minus right there. This minus is always there. So whatever you have for your b, be it positive or negative, you take it exactly as it is and plug it into b, keeping this minus out there. So we have this plus or minus the square root of b squared, negative 6 squared, minus 4ac. A is 1, c is negative 19. And what do we divide by 2a? The entire expression divided by 2a, not just the radical piece. That's one mistake most people make. So 2a is 2 times 1. All right, now multiplying the signs. Minus times minus is what? What do you do when you multiply two minuses? There's a trick. The peace sign. I don't know if you already know it. For multiplying signs. So this is basically what it looks like. Just draw a little peace sign. And then you have kind of like a face, minus, minus, and then a plus. What this sign tells you is that when you multiply minus times a minus, you have a plus. If you multiply minus times a plus, you have a minus. And if you multiply minus times plus, you have a minus. Okay? So basically, when you multiply two signs that are the same, you always have a plus. All right, so here we have minus times minus. That means that's a plus. 6 plus or minus the square root. Now, what is negative 6 squared? Negative 6 squared is basically negative 6 times negative 6. Okay? So what do we get when we multiply negative 6 by itself? Negative 6 times negative 6. Let's multiply the signs first. Using our peace sign, minus times minus is what? Plus. Okay? So that's plus 6 times 6, 36. All right? When you're multiplying sign numbers, you do the signs first and then you do the number. Okay, now here we have minus times minus again. Minus times minus. That's plus, and then 4 times 19 is 76. All right, so please be careful with your signs. Try not to drop those negative signs because it could throw off your answer, all right? Now, let's simplify the radicand after writing out what 2a is, which is 2 times 1, which is 2. And then this becomes 6 plus or minus the square root of 36 plus 76 is 112. 112 divided by 2. All right? Now what we can do is we can split our fraction into two pieces. X can be written as 6 over 2 plus or minus the square root of 112 divided by 2. Now can this radical expression be simplified? Well, let's set it to the side and see. So the square root of 112. This is an even number. It ends with a 2, so I can take out 2. I am only going to extract prime factors, okay? And then 2 goes into 112 56 times. Take out another 2. 2 goes into 528. 2 goes here 14. And then 2 goes here 7. 7 is prime, so we stop. Now, when you're taking the square root, any two identical numbers, when you root them, you end up with one of them, right? So that's what the square root is. So these two 2's, if I take the square root of 2 times 2, the square root of those 2 is going to simply become 2. Okay? And then what you notice is that we have another pair here. What is the square root of 2 times 2? The square root of 2 times 2, again, is 2. And then 7 is by itself, so we cannot take the square root of 7. It needs another 7 in order to be rooted. So the square root of 112 is going to be, we have 2 times 2 on the outside, and then 7 stays on the inside. So let's go ahead and write down what that is. All right, so it's going to be 2, this 2 that came out, times this 2 that came out, times the square root of 7. Okay, this 7 stays underneath the radical because it doesn't have a partner, identical partner to break out with as a square root. 2 times 2 is 4, root 7. So the square root of 112, the simplified form, is 4 root 7. So we are now going to have x equals 6 over 2 is 3, plus or minus 4 root 7 divided by 2. All right, now we can divide the top and bottom by 2 here. So let's go ahead and do that. Divide by 2, divide by 2. And then we're simply going to have x equals 3 plus or minus. So 2 goes here 1. We divide by 2, and then 2 goes here 2. It's going to become 2 root 2. Actually, it's 2 root 7. This radical right here is 7. Let's fix that. Sorry about that. So the radicand is 7. So we have 3 plus or minus 2 root 7. Have a 7 here, 7 here, 7 here. So we have a 7. All right, so there goes, these are the roots to your quadratic equation. So let's see, what is our answer? 3 plus or minus 2 root 7. So there you have it. All right, let's take a look at problem 3. It says, which statistic would indicate that a linear function would not be a good fit to model a data set? So any data set that looks like a line, a straight line, the pattern can be modeled using a linear function. Okay, so any function with a correlation coefficient that's close to 1 can be modeled using a linear function. So let's take a look at 1 and 2. 1 and 2 are giving us values of a correlation coefficient. So is 0.93 close to, it could be close to -1 or 1, okay? So if, let's write down the remark, if R is close to -1 or 1, it can be fitted with a linear function. Okay, if it's fitted, that basically means it's a good fit. A linear function is a good fit. Okay? Alright, so let's take a look at, go back to question, option number 1. R is 0.93. Is this close to -1 or 1? It's close to -1. So this function can be modeled using a linear function. All right, a linear function will be a good fit for this model. All right, how about the second one right here? What do we think about this? This is perfect because it's exactly 1. So you can model this perfectly with a linear function. How about option 3? We have a graph. Can you look at the pattern of the line, the points? Can this be easily modeled with a linear function? If you look at these points, what kind of line or graph would you instinctively desire to draw? You will want to draw something that looks like this. Something that looks like that. All right. What is this? This is a parabolic function. Okay. This is a parabolic function. It is best, this pattern of numbers, this data set is best modeled using a parabolic function, not a linear function, because the pattern is in the shape is in the format of a parabola. Okay, so our answer is going to be option number 3 because it does not follow that pattern. If you look at option 4, if you notice how the points are progressing, if you want to draw a line of best fit, it's going to be a straight line, something like this, right down the center. So number 4 is good also. So the only one that cannot be modeled with a linear function is number 3 because the points follow the path of a parabolic or quadratic function. All right, let's take a look at number 4. It says, on the set of axes below, graph the function represented by y equals the cube root of x minus 2 for the domain -6 to 10. All right, so first thing you want to note is, remember, is how the cubic function looks like. All right, the cubic function looks something like this. All right, so what is happening is that the cubic function has been shifted to the right by 2 units to the right. So if this is the standard cubic function, it's going to be shifted somewhere to the right like this. All right. So in order for us to graph a nice cubic function, we'll need at least 5 points to generate our graph. Okay. Since it's shifted 2 units to the right, we can automatically tell that 2 is going to be the central point of our graph. So the beauty of this graph can be highlighted when we select the right values to generate the graph of our function. Okay. So let's make our x and y chart. We need at least 5 points to make this happen. So this is x, and this is a cube root of x minus 2. All right, I'm going to make 5 rows. So this is first row 1, row 2, row 3, row 4, and then the 5th one down here will be row 5. Because of that shift, I know that this function is centered around 2 because it's shifted 2 units to the right. So we're going to put a 2 here. And then our extreme points are -6 and 10. So 10 up here. And then we have, let's put -6 here. All right, so let's calculate the outputs of these inputs. Okay. Then it can help us determine what to select for these intermediate values here. So for the upper bound, which is 10, we're going to be taking the cube root of 10 minus 2, which is a cube root of 8. Cube root of 8 is 2. Okay, cube root of 8 is 2. So there goes our one of our outputs. And then for 2, we're going to be taking the cube root of 2 minus 2. Cube root of 2 minus 2 is a cube root of 0. What is the cube root of 0? Cube root of 0 is 0. Okay? And then for -6, we're going to be taking a cube root of -6 minus 2. Now, how do you compute -6 minus 2? Whenever you're combining numbers, if the signs are the same, what do? You add and keep the signs. So since the signs are the same, we add the 2 numbers to get 8 and you keep the sign. The cube root of -8 is -2. All right. Now, what can we pick for these intermediate values here? To help us determine what to select, we just need to think about the cubes. Okay, so what is 0 cube? 0 cube is 0. That's what we did here. And then we have 1 cube. What is 1 cube? 1. What is 2 cube? 2 cube is 8. Check this out. We have 8 here. We've already made use of this input and this input. The what we want to work on now is this one right here. So what terms can we select for x that will give us plus or minus 1 for the argument or for the value of our radicand? Okay? If I selected 3, for example, what is 3 minus 2? 3 minus 2 is 1. That's a good value. How about I select 1? 1 minus 2 is -1. That's good also, because when I take the cube root of these values, I'm still going to get my desired output. Okay, so the two numbers that I can use to make this work are 3 and 1, because when I plug them in, I'm going to get a number that I can take the cube root of. Okay, all right, so let's do it. So the cube root of 3 minus 2 is 1. So the cube root of 1 is 1. And then now we have the cube root of 1 minus 2. That's going to give us -1, because when the signs are different, you subtract and keep the sign of the bigger one. The cube root of -1 is -1. All right, so we have these nice outputs that we're going to graph. So let me draw my graph again, my table again, nicely constructed, so it's easy for us to graph without getting confused with all the work that we did just now. So let's go ahead and make the table. This is my x, and this is my y. When x is 10, y is 2. When x is 3, y is 1. When x is 2, y is 0. When x is 1, y is -1. And when x is -6, y is -2. All right, let's go ahead and generate our graph. All right, so if you notice, this is a very symmetric curve right here, symmetric with respect to the origin, so let's keep that in mind. So 2 and 0, where's 2, 0? This is my x-axis, y-axis. 2, 0 is right here. And then 3 goes to 1, 3 goes to 1. And then we have 10 going to 2. So this is 3, 4, 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 goes up to 2. That's one piece of the the third root function, or cube root function. And then 1 goes to -1. 1 goes to -1. -6. 1, 2, 3, 4, 5. This is -5 right here. And then -6 is right here. -6 goes to 2. Okay? Now, if you notice, we were asked to go from -6 to 10. So we cannot go beyond these points. We have to stay in here. All right? So if you connect the dots, just do the best you can. Go through here like that. And then it curves a little bit. And it goes like that. And like that. And then you go straight and stop right there. Bam. So this is basically what the graph of the cube root of x minus 2 looks like. That's the original function that we were asked to draw. And basically you can see the translation here. This is a cubic function, a cube root function that has been shifted. You see the shift? It has been shifted 2 units to the right because of this x minus 2 here. So this is more than enough for us to get full credit for this problem. All right, let's take a look at problem number 5. We're to solve the quadratic equation by factoring. Now, the first step in solving quadratic equation by factoring or by the quadratic formula like we did in number 2 is to put it in standard form. What is standard form? You set it equal to 0 with the power of each term in descending order. Okay? So we have 8m squared plus 20m equals 12. So we have to set it equal to 0. So we subtract 12 from both sides. Subtract 12, subtract 12. That yields 8m squared plus 20m minus 12 equals 0. Okay? So now it is in standard form. Okay, now before we start to factor, we want to ask ourselves, is this a reducible equation? Is there a common factor with 8, 20, and 12? Is there a common factor? Well, what we can do is we can break down these numbers into their prime factor decomposition and see what is common to all three, and that common term can be factored out of all three of them. Okay, if you just by inspection, if you know your multiples, you can clearly see that the GCF of these three terms is in fact 4. But if you don't see it, all you do is you take the numbers out and break them down. So 8, 2 goes into 8 since it's even. 4, 2 goes into 4 since it's even. 2. So 8 is 2 times 2 times 2. That's the prime factors of 8. 20 is even. 2 goes there 10 times. This is even. 2 goes here 5 times. So 20 is basically 2 times 2 times 5. Okay? And then the last one we have is 12. 2 goes into 12 6 times. 2 goes into 6 3 times. So 6 is 2 times 2 times 3. All right, so let's go ahead and write it here. So we have for 8, 2 times 2 times 2 times m, plus for 20 we have 2 times 2 times 5 times m, and then for 12 we have 2 times 2 times 3 equals 0. So you notice what's happening here is that each term has 2 times 2 repeating. Okay, that's the greatest common factor, which is 4. So if we factor them out and combine them together, we'll have 4 on the outside. Now, if you factor out 4, what do you have left? When you factor out 4, these terms, kind of think of them as disappearing. Okay, you're dividing, when you're factoring, you're dividing every single term by that factor that you extracted. So you're left with 2m squared plus 5m minus 3 equals 0. Now what can we do? To simplify this equation, we can simply divide both sides by that number we factored out. So now we have a simpler quadratic equation. 2m squared plus 5m minus 3 equals 0. Okay? Now we're going to factor this using the x game and factoring by grouping. So let's go ahead and make the x. AC goes on top and B goes on the bottom. So AC is negative 6 and B is 5. So how did I know that AC is negative 6, B is 5? Well, just like we did with the quadratic formula, this is A, B, C, like we did in number 2. That's standard for quadratic equations. So on the top is AC and on the bottom is B. Now we're going to play the x game. What is the x game? You might already know what it is. You think of two numbers that multiply to give you the top and add to give you the bottom. All right. So this is a very tricky problem because you have more than one combination that appears to be the solution to the game. So we have 6. We're looking for factors, two numbers that multiply to give you 6, that when combined give you plus or minus 5. All right. So 6. What two numbers multiply to give you 6? Integer multiples. 1 times 6 is 6, and then 2 times 3 is 6. We have a complete list. Now combinations. You notice that a combination of this can give you 5, and a combination of this can give you 5, right? So which one is correct? Well, we can just pick a pair and test it and see if it works. Okay, so let's try 1 and 6 first. 1 and 6. How can I make their product negative and their sum positive? Is it possible? Since your sum is positive, that means the bigger number must be positive, and this is negative. Negative 1 plus 6, is it 5? Yes. Negative 1 times 6 is negative 6? Yes. So this is excellent. 2 and 3 is like a distractor, but they won't actually work. So what do we do now? Well, if the coefficient is not 1, like you have a 2 as a coefficient for A, then you cannot jump to the factored form. You must factor by grouping. Okay, so let's go ahead and do that. We have 2m squared. Now see these two numbers right here. I'm going to replace 5m with a combination of those two because that's the whole objective of this x game. We want to look for two numbers, one with a common factor with 2, the other with a common factor with 3, that add to give you 5. All right, so we have negative 1m plus 6m minus 3 equals 0. Now that we have four terms, we can divvy down the center behind this sign and factor by grouping. Okay, so let's go ahead and do that. How do we factor by grouping? In this one right here, I can break this down. This is 2 times m minus 1 times m. And then this one can be written as 2 times 3 times m minus 3 equals 0. Now, notice in the first two terms to the left of my partition, m is a common factor. So what does that mean? Factor it out. So factor out m, and we're left with 2m minus 1. On the right side of our partition, what do you notice? You notice that 3 is common. And also, whatever the sign is here, that's what you bring down. We're bringing down a plus, factoring out a 3. If you bring down a plus, there is no change in the sign because minus over plus is minus. So if you factor out these 3 and this 3, you're going to be left with 2m minus, what's going to be left here? 0? No. When you factor out, remember we talked about it earlier here, factoring is the same thing as dividing. So when you're factoring out 3, we're dividing this term by 3, which gives you 2m. And if you divide this by 3, you get 1 equals 0. All right, now we're going to factor again. Now, another thing to check your work before you factor, when factoring by grouping, these two quantities must always be identical. If they are not, then you made a mistake somewhere. So since they're identical, it gives us the freedom to factor them out. So we'll have 2m minus 1. If you factor out these two terms out of this entire expression right here, what will you have left? You're going to be left with m plus 3. Okay, so here you have m plus 3 equals 0. All right, to finish this off, we have to use a zero product property. So what we're going to do is we're going to set both factors equal to 0 because if the product of two quantities is 0, one or the other has to be 0. Okay, all right, so let's go ahead and solve this. So for this one is a two-step algebraic process. Add 1 to both sides. 2m equals 1, and then divide by 2. And your first root is 1/2. This is a one-step algebraic problem. Just subtract 3 from both sides, and then you have m equals -3. So our solutions are m equals -3 and 1/2. All right, so that's that. Well, thanks so much for taking the time to watch this presentation. Feel free to subscribe to our channel for updates to the remaining parts of this review series. More clips can be found on mathexpertserve.com/testprep. Thanks again for watching, and have a wonderful day.